So good evening. This is CS150 CSRF Lab by Antonio Lim and C, group letter E. So to start off with the lab, we have to first understand what is this CSRF attack. So in short, this is the cross-site request forgery, and it's a web security vulnerability that allows the attacker to induce users to perform, actions that they do not intend to perform. And with this, an attacker can actually circumvent the same origin policy which we discussed last week, which is designed to prevent different websites from interfering with each other. And because of this, some actions that can occur are a change of email, a change of password, and even a fund transfer that isn't, that wasn't even that's against the user's desire. So this is from the attacker. And depending on the nature, an attacker may gain full access to an account. And so three things that that need to happen for a CSRF attack to actually occur is first you got to have the relevant action, and then second is you got to have a cookie based session handling, and for the third is you got to have no unpredictable request parameters. So these have to be set. And so in this lab, we'll be, investigating and learning about how the CSRF works more, especially as we test it out and, actually see how it works in the code. And so for task 1, we were tasked with observing the HTTP request. And so as you can see here in this CSRF lab site, so we were able to see several HTTP GET requests and HTTP POST requests, which were captured by the HTTP header. So, this from Mozilla Firefox, a live add-on. And so we got these screenshots after logging as admin, and you can see we were able to see the token, the username, admin, these things. So these are the GET and HTTP POST requests, right? Also same here, the GET. And now for task 2, we were tasked to conduct the CSRF attack using the GET request. And we'll show you later in the next slide the live HTTP header that was produced when we added Alice as a friend. And currently we were logged in as Bobby. And we used this as a reference or pattern in constructing the code for our CSRF attack, which we'll show in a little while as well. And so in the GET request, it can be seen that one of the parameters is the user ID of the user that we're adding. So in this case, Alice's user ID is 39, which is why add $friend equals 39. And as you can see here, so there's the cookie, right? Right over here, the GET requests. Okay, logged in as Alice. And so while we were logged in as Bobby, we will post a blog post containing the link of the malicious file. So this will automatically add Bobby as a friend. And we sent it. We added it. Not sent, but we added the blog post. And the screenshot below shows the output when we view the page source of the members page of the trusted field, or trusted website. And remember, Alice is 39, Bobby is 40, right? And this is the source from the source code, right? And so going back to the first, screenshot of the task, we would just copy the URL of the GET request and adding Alice as a friend and replace the corresponding user ID to Bobby's user ID. So from 39, it's going to become 40. And we will put this URL inside an image attribute, as you can see here, right? Which produces a new GET request. And when this index.html is modified and Alice actually clicks on the link, the URL inside the said image, right, is executed again. So in this image, we'll actually produce a new GET request, right? And again, as you can see, we set the width and height to 1 so that the dimensions of the image are very, very, very small. So that when Alice, so that she won't notice that there's malicious code, right? And there's a CSRF attack, so there's no script inserted. And that's why we're using the session and abusing that, right? And so that when Alice clicks on it, the LG site will think that Alice is really adding Bobby as a friend, right? And so, yeah, as After Alice clicks on the link, Bobby is now added to her friends list. So a success. Next thing is for task 3 is we were tasked with conducting the Csrf attack, but this time using a post request. And right, so sorry, before that, so as you can see, Alice, after clicking, Bobby is now her friend. Anyway, so using the post request, below is the captured live HTTP header after adding hi Bobby in the brief description field, right? And now this is only for testing purposes, and we'll use the information captured to pattern our own attack, right? So live HTTP header. And so this is the code that we used, right, to execute our attack. And again, we modified index.html providing the lab manual and changed the necessary fields in line 11, right, line 12, line 14, and line 20, right? And so, as you can see, so from 30, so in the previous task we identified Alice ID, and that's why the GUI ID value is 39, right? And the action we're going to do is this, right? So the next thing is that we need to do is for us to get Alice to visit the malicious website that we created, right? Using Bobby's account, we send a message to Alice so that when Alice clicks on the link, her profile will be modified. So this is when we're Bobby. So we're composing a message, click on the link, and that's, right? So the screenshot below is logged in as Alice, right? So she saw the message in her inbox, and after clicking on the link, you can see that the profile is updated as seen in the screenshot. So Alice, Bobby is my hero, right? So question 1 is just like what we did in the previous task. We can identify Alice's ID by inspecting the page source. So we'll do that in a second, right? It's just like a while ago, right? And question 2, he cannot perform the Csrf attack to anyone who visits the malicious site because every user would have a different user ID, and in our code we only specify the user ID to be 39, which is Alice's code, right? We have to modify the code so for different users, different IDs. Simple as that. And now for task 4, it's implementing a countermeasure for ELGG, right, or ELG. So in order to edit actions.php, we use the command sudo vim, so /var/www csrf/elg/engine lab actions.php, and we have to be the root user, right? Sudo. So we use the sudo command, and then we made use of the vim editor to edit the file. We comment out the file, return true, this one, right? And so when we comment out this line, it actually enables the countermeasure against Csrf attacks, right? And we remove Bobby as Alice's friend, and we do task 2 and task 3 again to check if our Csrf attack will be successful or not, right? After performing task 2 again, click on the same malicious site with Alice currently logged in, so you can see the attack failed because Alice has no friends. The step that we did previously prevented this, right? This one, right? So it enables the countermeasures, right? And that's why there's no change in Alice's profile. Same thing with task 3. Again, it's simply because the countermeasure is on, and it prevents it immediately. So the secret tokens in the HTTP request captured using live HTTP header are the unique token and timestamp which are sent in each request. And when we turn on the countermeasure by commenting out the return true line in the PHP file, as seen here, right? The unique token, excuse me, and timestamp are compared and checked if the values are valid in accordance with the session of the user. And that's why when you perform an attack with the countermeasure on, it causes the secret token validation to fail because it is identified as a cross-site request and not a request from the same user. Okay? And so that's pretty much it for this lab, and that concludes the CSRF lab. Thank you.